Hi, my name is Yemao Zhou, and I'm presenting my physics final project. The first section is to talk about how I made my reaction strip. Well, I made two. The first one is 46 centimeters long, and the second one is 91 centimeters long. I choose the kind of paper whose quality is similar to the printing A4 paper, because it is not too thick to fold and it's not too fragile. The paper's width is about 20 centimeters. I folded twice so that my strip's width is about 5 centimeters, and the paper's length is 26.6 centimeters. It means I need to bond a few little strips together. And when I bound two little strips, I overlapped the head to tail for about 6 centimeters to make sure it's connected tightly, like this. There are two strips, and I overlapped them like this. And then I used the Scotch tape to fix them. Then I wrote down the mark of length and the mark of matched falling time on the strip. And also, in order to keep the strip straight during my experiment, I strengthened the edge of the strip with some Scotch tape, like this. You can see at the edge there are some Scotch tapes, because if the strips bends during the experiment, it definitely gonna affect the experiment result. And the second section is about the equation I used. Well, the original equation is x equal to 1/2 at squared, and in which a is g. So x equal to 1/2 gt squared, and so the t equal to the square root of 2x over g. And because I use the centimeters as the unit of the length and the second as the unit of time, so in my first strip, the t equal to the square root of 2x over 100g. And in the second strip, the equation is a little difficult. T equal to the square root of 2 times the sum of x plus 10 and over 100g, and minus the square root of 2 times 10 over 100g. Because in the second strip, because in the second experiment, it has an initial velocity, and in the experiment I placed the strip 10 centimeters above the experimenter's hand, and so the actual reaction time should be the total falling time minus the time it spends reaching the experimenter's hand, which is the square root of 2 times 10 over 100g. And then I'm going to talk about the equation in the Excel spreadsheet, and there are three spreadsheets. The first one is called equal reaction time increment, and I use x equal to 1/2 at over 1000 squared times 1000, because in the Excel I use the millicentimeter as the unit for the length, and the milliseconds for the unit of time. Well, in the second spreadsheet, which is called equal falling time increment, the equation is the equation is similar to the equation I explained in last page, which is t equal to the square root of 2 times the sum of x plus 10 over 1000g minus the square root of 2 times 10 over 1000g, and then times 1000 at the end. Oh, in this section I should post the YouTube link. And then is to talk about the equation I used for making my reaction strip. Well, this is for the first reaction strip, which is 46 centimeters long, and you can tell that from here. It shows about 460 millimeters, and from here it shows the time is a little above 30,000 milliseconds. And the equation I use for this strip is showed here down here. Time t equal to the square root of 2x over 1000 g and times 1000. And here's for the second reaction time strip, which is 960 millimeters long, and you can see it from here. And the reaction time is also a little above 3,000 milliseconds. The equation I use is showed here. T equal to square root of 2 times x plus 10 over 1000 g minus square root of 2 times 10 over 1000 g and times 1000. And here is the experiment data for 10 female and 10 males. And here and the names I put in pink is females, and the name I put in blue is males. And the experiment above the yellow line is without the destruction, below the yellow line is with the destruction. And from here it shows the mean standard deviation, and also here mean standard deviation. And down here it shows the difference in average reaction time with and without the extraneous stimulus. And the second one is for the second reaction time strip, which is with the initial velocity. And also the pink means female and the blue means male. And the experiment above the blue line is without the destruction, and below is with the destruction. Here are the mean standard deviation, and here's the difference in average reaction time with and without the extraneous stimulus. And the last section is about the questions. Well, in your opinion, did the extraneous stimulus you used affect subject reaction time? Yes, I think it did. Can you come to a conclusion about the reaction time of males versus females when there are minimum extraneous stimuli? Well, I remember that you told me that the male's reaction time is usually a little bigger than the females, but in my experiment, the result is a little different, because the reaction time of males are less than the reaction time of females, no matter there are destructions or not. Well, the last question is, do your results have any bearing on the effect of talking on the cell phone while driving? Well, I think because when there is a distraction, people's attention is less focused, so it will be dangerous when you talking on the phone. It will be dangerous if you're talking on the phone and when you're driving. That's it. That's my presentation about the